Welcome to our lesson on creating histograms. In this video, we'll learn how to construct histograms step by step and understand why they're such powerful tools for visualizing data. A histogram is a graphical representation of the distribution of numerical data. It's similar to a bar chart, but instead of comparing different categories, a histogram shows the frequency of data values within continuous ranges called bins or classes. Let's start with a real-world example. Here's a dataset of commute times in minutes for 20 employees at a company. Step 1. Determine the range of the data. Looking at our dataset, we can see that the minimum value is 12 minutes and the maximum is 42 minutes. So, the range is 42 minus 12, which equals 30 minutes. Step 2. Choose an appropriate number of classes or bins. A common guideline is to use between 5 and 15 classes, depending on the amount of data. A rule of thumb is to use approximately the square root of the number of data points. Since we have 20 data points, and the square root of 20 is about 4.5, let's round up and use 6 classes for our histogram. Step 3. Calculate the width of each class. We divide the range by the number of classes. 30 divided by 6 equals 5. So each class will have a width of 5 minutes. Step 4. Define the class boundaries. Since our minimum value is 12 and our class width is 5, our classes will be Class 1, 12 to 16, Class 2, 17 to 21, Class 3, 22 to 26, Class 4, 27 to 31, Class 5, 32 to 36, and Class 6, 37 to 42. Notice that I extended the last class to include our maximum value of 42. Step 5. Count the frequency of data points in each class. Let's tally our data. Class 1, 12 to 16, has 3 values, 12, 15, and 15. Class 2, 17 to 21, has 6 values, 17, 18, 18, 19, 20, and 20. Class 3, 22 to 26, has 5 values, 22, 22, 24, 25, and 25. Class 4, 27 to 31, has 3 values, 28, 29, and 30. Class 5, 32 to 36, has 2 values, 33 and 35. Class 6, 37 to 42, has 1 value, 42. Step 6. Organize these frequencies into a frequency table. This table clearly shows the distribution of our commute time data. Step 7. Now let's draw the histogram. First, we'll set up our axes. The horizontal axis represents the class intervals and the vertical axis represents the frequency. Now, we'll create bars for each class. The width of each bar corresponds exactly to the class interval, and the height corresponds to the frequency. And here's our completed histogram. Notice how the bars are adjacent to each other with no gaps in between. This is a key characteristic of histograms. Step 8. Interpret the histogram. Let's analyze what our histogram tells us. The center of the distribution appears to be around the 17 to 21 minute range. The shape is slightly skewed to the right, meaning there are a few longer commute times. The most common commute times are between 17 and 21 minutes. The spread of the data shows that most employees have commute times between 12 and 31 minutes, with fewer having longer commutes. Now, let's discuss some common mistakes when creating histograms. Mistake number 1, leaving gaps between bars. Unless a class has 0 frequency, histogram bars should be adjacent to each other. Mistake number 2, using unequal class widths without adjusting frequencies. If you must use unequal widths, you need to adjust the heights accordingly. Mistake number 3, misaligning bars with class boundaries. Each bar should precisely cover its class interval. Let's briefly look at some variations of histograms. A relative frequency histogram uses percentages or proportions on the vertical axis instead of counts. This is useful when comparing datasets of different sizes. A cumulative frequency histogram, also known as an ogive, shows the cumulative count or percentage at each interval. This helps visualize how data accumulates across the range. In conclusion, histograms are powerful tools for visualizing the distribution of numerical data. We've learned the step-by-step process for creating a histogram. Determine the range, choose the number of classes, calculate the class width, define class boundaries, count frequencies, create a frequency table, and draw the histogram. Remember to avoid common mistakes like leaving gaps between bars or misaligning bars with class boundaries. Histograms help us quickly see the shape, center, and spread of our data, making them invaluable for data analysis. Thank you for watching our tutorial on creating histograms. With this knowledge, you'll be able to effectively visualize and analyze numerical data distributions.